Hello everyone. In this video, I will be explaining about derivative of implicit equation. Okay, implicit differentiation is a technique we use to find a derivative when y is not defined explicitly in terms of x. So up to this point, most functions have been expressed in explicit form. For example, y equals 3x minus 5. Y is on one side of the equation, the variable x is on the other side. So y is alone. But in implicit equation, x and y are together in the equation and there is no way of isolating y. So it's very difficult to express y as a function of x explicitly. So we will apply uh, implicit equation differentiation. So when you differentiate terms involving x alone, you can differentiate as usual by using simple differentiation rules. However, when you differentiate terms involving y and x in the equation, if there is implicit equation, we will apply different techniques. So what are the ways of solving implicit equation differentiation questions? Let's take a look at the ways. So differentiate both sides of equation with respect to x and collect all terms containing y prime on one side of the equation, factor y prime out, and solve for y prime. So, if you take, okay, let's suppose you have x as a function, you take derivative of x with respect to x. So it's the same as writing this as the function, which is x, over dx, which is equal to x prime, derivative of x with respect to x, is 1, right? This is what we have been doing so far. On the other hand, if you have y as a function, you take derivative of y prime, and you can also write this as the function which is y over dx. There is no simplification. We will leave it as it is. The derivative of y prime is not 1. It's not a constant number. It is just y prime, or you can express y prime as dy over dx. So since x prime is dx over dx, which is 1, the y prime can be also expressed as dy over dx, which is not 1. So y prime will remain as y prime, or dy over dx. On the other hand, x prime will be written as 1. So this is what we are going to do when we solve questions. First question, let y squared equals x, then find y prime. So we take derivative of both sides. Derivative of y prime, you apply basic differentiation rules, the power rule, to y. Derivative of y, you treat y as u. So if you have u squared, what do? You bring the power down in front and multiply the result by the derivative of the base, u prime. So this is chain rule for power chain rule. So we'll do the same here. Derivative of y squared is 2y multiplied by y prime. Y prime is not 1, it's y prime, or dy over dx. Okay, in some questions you'll see it's asked as y prime. Some questions, the question will ask this as dy over dx. So they're both same. Okay, 2y prime equals derivative of x with respect to x is 1. I need y prime alone, so get rid of 2y, divide both sides by 2y. So y prime is alone on the left, on the other side we have 1 over 2y. Right? It's not as difficult as it seems. When you get the hang of it, it's easy. Okay, check it out. Question here. What's y prime? So I have x's, y's all together in one equation. Everything is together. X and y are together on one side of the equation. So we apply implicit equation differentiation. So take derivative of each term one by one. Derivative of y cubed, apply power chain rule. 3y, derivative of y, dy squared, sorry, we decrease the power by 1, times derivative of the base, y prime, plus power rule, 2y, decrease the power by 1, it's 1, times derivative of the base, y prime, minus derivative of 5y, 5, multiplied by derivative of y prime, minus derivative of x squared with respect to x is 2x, x prime which is 1, so I'm not writing it, just 2x equals 0. Now I have y primes all over the equation. Here y prime, here y prime, here also y prime. So I'll collect these y primes. So take y prime as a common factor, put the remaining inside the bracket. 3y squared from the first term, from the second term 2y, last term negative 5, and negative 2x has no relation with y prime, so we can move it to the other side of the equation. Now, to get y prime alone, I should divide both sides by 3y squared plus 2y minus 5. So now y prime is alone on the left. On the right, I have 2x over 3y squared plus 2y minus 5. So that's what my y prime is. Alright, if you get the idea, you can solve every type of question about differentiation. It's not very common question in Wazari. We don't have much. We have a few of them. Here we have maybe 4 or 5 questions. We don't have much. Okay, a test prep question and mystery question. The same question came 2 times in Wazari so far. So how do I solve this? It's asking about dy over dx. See, in the previous questions we're asking about y prime. This is asking about dy over dx. The same idea. Y prime is same as dy over dx. It means differentiate with respect to x. So x squared with respect to x, 2x only. There's no x prime. Minus. We have multiplication here. We have product rule. Apply differentiation product rule. Derivative of first, derivative of x, 1 times second, y, plus first, which is x, times derivative of second. Derivative of y is not 1, it's y prime, plus derivative of y squared. Apply chain power rule to y times derivative of y prime, equals derivative of 1 is 0. Now, let's distribute this minus to the bracket. So x minus y minus xy prime plus 2y y prime equals 0. Now it's time to collect y primes. Here I have one, here I have another. So bring everything else to the other side of the equation. Take y prime as a common factor out. Put the remaining in the bracket. Negative x plus 2y. And I have nothing to do with these two, so let's move it to the other side of the equation, which makes y minus 2x. Now, in front of y prime is multiplied by negative x plus 2y. So divide both sides by negative x plus 2y. So y prime equals y minus 2x all over negative x plus 2y. So I got my y prime alone. Y prime means dy over dx. Right, so that's the answer. Okay, another exercise and ministry question. If x is equal to tangent y, what's dy over dx? What's y prime? So let's take a look at the question. X. So remember, derivative of tan has two ways of taking derivative. It's either, if there's tangent u, the derivative is either u prime over cosine squared u, or on u prime times 1 plus tangent squared u. So we use one of them. Let's see which one works. We don't know. Without trying, we cannot know. So let me try the first way first. If it doesn't try, I'll use the second way. Derivative of x with respect to x is 1 equals derivative of tan, as I did here, with respect to y is tangent y with respect to x is y prime divided by cosine squared y. So cross multiply, y prime is alone, then it's cosine squared y. Do I have cosine squared y here in options? No, I don't. But I see an equivalent form. How so? Let's remember a trigonometric identity. Cosine squared plus sine squared equals 1, right? If cosine squared plus sine squared is 1, then cosine squared alone will be 1 minus sine squared. So when you move sine squared to the other side, cosine squared is 1 minus sine squared. So in place of cosine squared, I can write 1 minus sine squared y. So y prime is cosine squared y, which I cannot see in options, so I should rewrite it, manipulate the answer. So it's equivalent to 1 minus sine squared y. So this is the answer. This is a nice question. It's using two different information. Okay, last question. I'm gonna leave the rest to you. Which of the following is false? 2023 first attempt mystery question. Let's try options one by one. D over dx. So this is about derivative, right? Take derivative of the first option. Option A. Take derivative. Derivative of ln. Derivative of the angle. 3 over x squared derivative divided by the angle. Remember, if the variable is in denominator, we can move it to numerator to use power rule, so we can rewrite this function as 3 times x to the minus 4. So take derivative of this. Negative 4 in front, so negative 12 x to the negative 5, reduce the power by 1, over 3 over x to the 4. Let's write this as division. Let's move this negative exponent, get rid of negative exponent by moving the variable down. So negative 12 over x to the 5 all over 3 over x to the 4. So top fraction will be written first, multiply it by the reciprocal of bottom fraction. So this and x to the 4 from bottom will go, 3 and 12 will simplify, so I will left with negative 4 at the top, x at the bottom. Negative 4 over x, that's true. So I got the first option. Second option, the derivative of this. Derivative of 3 is 0. Okay. 2 times e to the 4 pi. Everything is constant here. We don't have a variable here. It's a number. E to the 4 pi is a number. Number multiplied by number, number. Derivative of a constant number is 0. 0 minus 0, 0. It's also true. Okay, try D. Try D. Derivative of cosine squared x. I should solve this. I need a space. Let's solve this here. So, derivative of cosine squared by starting with the power rule, bring down the power in front to cosine x, multiply it by derivative of the base, which is negative sine x. So it's negative 2 sine x cosine x, right? Which is not given as an answer. But we have an equivalent form. We have a trig identity here. What identity? 2 times sine times cosine is equal to sine 2x. It's sine 2x, and don't forget minus in front. Sine 2x. And that's also true. This is also true. See, in the previous question, the question made me use the identity. This question also made me use the identity. So trig identities are important. It's important in differentiation, it's important in integration, so it's important. This is also true. Apparently C is the answer, but let me solve to show you I'm out of space. Let me solve here. So derivative of sine square root of x. So derivative of sine is cosine multiplied by derivative of the angle. Derivative of the angle is derivative of square root of x is 1 over 2 square root of x. So it is cosine square root of x divided by 2 square root of x. What's missing here in this option? Denominator is same, but in numerator we don't have square root here. We don't have square root for x, so that's false. Option C is false. So these are the type of questions you may face in exam. So we covered everything about this topic.